it was for the range. I put just a number for the range instead of y equals.
I guess at one point I'm sure you had to be.
At one point I was
No,
failing.
you got full credit. I lost like 6 points on that. I remember it clearly now.
Okay. So today, guys, we're going to talk about inside angles. So we have already talked about central angles, like this one up here. A central angle, oh, don't do that. You know what's going to happen now? It's going to freeze.
See what happened was, his column skipped over 10-point assignment. It was the second assignment she put in, so she put it as 0. And it's cost too big. Because the things were worth 20 points in total and they're missing 10. No. Can't do it now. There's no way it's going to last time soon.
So might as well straight.
Yeah, and then next year I'll see. Stop now. It's going to last. It has to last. I know I can make that last time soon.
Okay, so central angle we've already studied. And a central angle is equivalent, you're kidding me, to the intercepted arc. Here we go. Save. All right. So whatever this angle is, the intercepted arc is the same. Whatever the intercepted arc is, the angle is the same. But today we're going to talk about an inscribed angle. And an inscribed angle is an angle vertex lies on the circle. Do you see the difference? Vertex on the circle, vertex at the center. This was the same. This is not. We'll talk about that in a minute. Intercepted arc is that arc that's in the interior part of the angle. That's what that means. Inscribed polygon, we already studied these. We constructed some stuff with the polygons, didn't we? Inscribed polygon means the vertices of the polygon lie on the circle, and circumscribed circle means the circle is around the polygon whose vertices lie on it. All right, so how do we find the measure of an inscribed angle? Well, the measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc. So if this arc, AB, had a measure of 2x, what would we say angle D was? Half of that, which is just x. So the measure of angle ADB is 1/2 the measure of arc AB. An inscribed angle is half the intercepted arc. Make sense? Central angle is the same, inscribed is half. So if we take a look at this, find the measure of angle S. So angle S is right here. Let's find intercepted arc. Well, there it is. It's RT. So the measure of angle S is going to be 1/2 the measure of arc RT, which is half of 60, which is 30 degrees. Any questions? Okay, and now we can kind of go backwards. If we know the angle, let's arc measure. So it's going to be twice that angle. So it's going to be twice 37. So the measure of arc QS is going to be 74 degrees. And we can just go back and forth. All right, now, if we look at this, do you see that QS right here is a semicircle? So if we wanted to know RQ, we would just take this 180 and subtract away the measure of QS. Well, QS is 74, so RQ would be 106. Any questions? Okay. You try 1 and 2 at the top of the next page.
Okay.
Please try numbers 1 and 2 at the top of the next page.
Oh my gosh. This is
500.
so easy.
GHJ.
I was thinking.
Okay, so GHA is this angle here, which is half the intercepted arc. Did you get 50 degrees? All right, the measure of arc CD is going to be twice the inscribed angle, so it's going to be 80 degrees. Any questions?
No.
Okay, let's look at this carefully, guys. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So if we look at this, do you see that angle D and angle C intercept that arc AB? So whatever AB is, this is half of it, and this is half of the same thing. So don't they have to be the same?
Yes.
So whenever we have inscribed angles intercept the same arc, they must be congruent. So ADB is congruent to BCA. Okay, let's look right here, though. Do you see that angle A and angle B are also congruent? Because they both intercept this arc. So we can look at that both ways. Okay. All right, let's look at angle B. Do you see that angle B intercepts that arc? Does everyone see that? Well, isn't that arc a semicircle? So what does angle B have to be? And what does AC have to be? The diameter. The hypotenuse of that right triangle is the same as the diameter. So if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, which means switch it, if one side of an inscribed triangle is the diameter of a circle, then the triangle is a right triangle. And the angle opposite the diameter is a right angle. So the measure of angle ABC equals 90 if and only if AC is the diameter of the circle. Okay, now the last one's talking about a quadrilateral inscribed in a circle. And we're looking at opposite angles here. So here's angle D, and the intercepted arc for angle D would be here. Does that make sense? And since we're talking about opposite angles, now I'm going to look at angle F here. And its intercepted arc would be from here to there. Does that make sense? Well, do you see when I do opposite angles, I got the whole circle when I put together the intercepted arcs?
Yeah.
How many degrees are in the entire circle? 360. And for an inscribed angle, don't we do half of that?
Yeah.
What's half of 360? 180.
180.
Well, anytime we have opposite angles in an inscribed triangle, an inscribed polygon. Nope, let me try that again. Inscribed quadrilateral, opposite angles are supplementary. They add up to 180. And that is why opposite angles, the measure of angle D and the measure of angle F equal 180. Or the measure of angle E and the measure of angle G equal 180. Opposite angles are supplementary in an inscribed quadrilateral. Okay, let's try some problems. You try 3 and 4 at the top of the next page. Actually, bottom in the next page.
They're the same.
Yeah, he'll show his golf cart.
Okay, did you get 31 and 11.2?
Yes.
Does that make sense? Okay, if this is 31, then this arc is 62. Does that make sense? Well, if this arc is 62, then this angle right here, which intercepts that arc, has to be half of that. So it is also 31. Both of these two angles intercept the same arc, so they are congruent. All right. We're going to do the first one together here. Here we have a quadrilateral inscribed in a circle. So what do we know about opposite angles? They add up to 180. So x plus 88 equals 180. So what is x? 92. Okay. And then y plus 100 equals 180. So what is y? 80. Okay, you try the next one.
What?
We are recording, by the way. Okay, did you get 30 and 15?
Yeah.
Oh.
Yes. Okay.
Oh. On the actual measurements. It's variable. Okay.
I got it.
Okay. Is there something on there that we can tell must, with all certainty, a diameter? Why is JL? You are correct, but why is JL a diameter? Because what kind of angle is this? 90 degrees. So that intercepted arc has to be twice that, has to be the diameter. Good. All right, you may start your homework. It is on your calendar. If you're absent today, pull up the calendar and take a look at the problem numbers that are for your homework.